Hayum. Hello everyone, my name is Hazel Hayum. I'm going to make a series of videos about PointNet. PointNet is a classical method of point code processing. I think the importance of PointNet of point code is like the importance of ResNet of images. So I think if you are studying 3D computer vision, I think it's very important to know about point cloud. What's the difference? Let me ask you a question. What's the difference between 2D computer vision and 3D computer vision? I think the major difference is about the depth. In 2D computer vision, you don't, for example, object detection or image segmentation, you don't have to consider about the depths. But in 3D computer vision, you have to think about the coordinate transformation. For example, an object in a world, its location is XYZ, and you project it on a 2D coordinates, and it's got a pixel value U and V. I think, and how can we get the depth? There are three methods of depth equation. The first is we can, if cameras can't get depth, so we can use other sensors which can get depth. For example, LIDAR. LIDAR use the principle of light, travel of light TOF, so it can directly get the depth of the object. So yeah, I think that's enough about the theory. Let's look at the paper. It's the PointNet can do multiple tasks. For example, classification or semantic segmentation. It's just like what one point cloud data means. Is it a mark or is it a table? And let's look at that. I'm not going to talk about the paper. Let me mention again that the majority of the majority of the videos is about code implementation. If you want to code PointNet from scratch, you can code with me. And I think the best way to improve your coding ability is doing a project. So I think PointNet is a good project to start from. And at first we have endpoints, and which point has three coordinates. For example, X, Y, Z, and we use TNet to do the transformation, and we project it to bigger dimension. And yes, and in this part we use max pooling to get the global feature. The reason why we use max pooling is because it's a symmetric function. And because for example, if you change 2 points and you exchange their locations, they are exactly same point cloud. So point cloud data must be robust to transformation. That's why we use TNet. And I'm not going to talk about the TNet, the math principle of TNet. Let me say it again. I think the main focus of this series of video is code implementation. And the reason why I use max pooling is because it's a symmetric. Function. So if we change their location, the result are the same thing. And then we got the global feature. And if we just doing classification, we can use a global feature to get the output results. And if we're going to do, for example, segmentation, you can concat global feature with local features. And in this video, I'm going to implement TNet. So yeah, yes, that's not. I'm going to share the link to this paper in the description, and let's do the coding. Yes. Just the normal import part. Let me create a class which called TNet. It inherits from n.module. We look at a class in deep learning. I think the two major part is innate and forward. Forward function is it's about when you call this object, it automatically pass the data you send in through the forward function. And first, let me create the innate function. And it's all about customs. And what we need to send into the class unit is a dim. In this case, for example, a point has three coordinates, right? So the dim equals 3, and number of points. Why we need number of points? Because in the max pooling function, we have to send in the number of points. So we are going to, for example, say to 2000, and this means that we have 2000 points, and each point is represented as XYZ. So I think it's quite easy. It has only two parameters. And we are going to code according to the pipelines in the paper. So in this part, yeah, and I think let me check the TNet part. I think it might be omitted in the original paper. So it just I think let me talk about what the TNet is going to do. It has, for example, it has at first we have n.3, and we are going to use count1d, and its function same as shared MLP. So we are going to increase the dimension to 64. Oh, sorry. And the same thing here, we are going to do it 3 times. And then we are going to use max pooling to get the I think it's like the global feature. And then we use linear n.linear just like MLP to decrease the dimension. And because we defined dim as 3, so it should be 9. The reason it's 9 because we are going to convert it to a 3 by 3 matrix. So let's yeah. So we just need to define count1D. So the input channel equals dim, and the output channel should be 64. And the kernel size should be 1. We increase the dimension to 1024. That's the now we are going to use. I think I made a mistake here. Yes, that because we are going to use max pooling, so the I think the dimension should be n because the kernel size of max pooling is 1024. And yes, I think yeah, I got it. So now we use the view function to convert it to a 3 by 3 matrix. And what it means, and we add a identity function matrix to it. And so the output, yes, I'm sorry about that mistake. The input is n points, and each point has 3 locations, and the output should be a 3 by 3 matrix. And if you, in terms of 3D coordinates, a 3 by 3 matrix means transportation. If you do matrix multiplication, if, on a 3 location, on a coordinate, in a 3D coordinates is like a rotation and rotation and movement. So it just transform transform one location to another. So you can regard the intuition of TNet is, for example, rotate an object. For example, it's a chair, and if you rotate it, it's still a chair. So that's that's the intuition of TNet math pooling. So it has three parts. One, the first we increase the dimension, and the second, I think we got global feature. And then we decrease the dimension. And last we have to add an identity function, identity matrix to it. Yeah, I think that's about TNet. So it's a building block of the PointNet. We are building a big project, for example, Python projects. You have to build the building blocks, and for example, if I have 5 building blocks, and I think this principle can apply to several domains. For example, if you are doing a complex task, first you divide this complex task into several easier ones, and until each part is manageable. So I think this part is manageable. The TNet is manageable. So it's a small building block of the whole PointNet. Yeah, I think that's a general learning technique. Yes, and you can also use array pooling. And in the original paper, it is mass pooling. I think the pooling principle is the same. It's just got global feature, and this method is also used in the PointNet architecture, the backbone of PointNet. And we have to define the max size, the kernel size to 1024. So actually, you can add the parameters here, but I think it's redundant. And it means that you got the max values from 1024 candidates. So the total numbers is, so yes, you just choose the biggest value through the 1024 numbers. Yes, and that's it. And we use linear function to the n.linear linear to decrease the dimension. I think it's more beautiful to add parameters here, so I'm going to do it. Yes, and I think we don't have to specify it, but I think it's more readable. So now we are going to decrease the dimension. And again, we are going to use three linears to decrease the dimension and until it's 9. So the input channel of this layer must be same as the output channel of the layer before. And the reason we are doing here because we want a init dim by init dim matrix, so it has to be the square of init dim, and then we're going to reshape it to init dim by init dim, which means 3 by 3 matrix. Yes, and yes, add an identity matrix to it. I think it's also just like the most of PyTorch deep learning models, we have to use batch normalization. And first, because we need to define 5 batch norm layers. And the reason we are going to set 64, which means we have, I'm not going to talk about the theory of batch norm. We are going to calculate 64 mean values, and 64 covariance. Yes. So because we have for each point, you can regard as the first. I mean, a point is represented by 3 numbers, and after we do the count 1, a point is represented by 64 numbers. Sorry. A point is represented by 64 numbers. And we are going to calculate the mean value of the first number of 2,000 points. So we are going to calculate 64 mean value, 64 covariance. I think they are just the same. No, I'm going to also type it. I think identity matrix. Yeah, let me define the identity matrix here. This means that the identity matrix is also learnable, so we can do the gradient by propagation on this matrix. And because we have the batch size, so we are going to copy it batch size times. Yeah, let's define the batch size here. So I think you can got you can got the batch size of the input through this, but I'm going to send because we are going to send it in the forward function, so I think it's better to put it in the forward function. And so let's move it to the forward function. Yeah, I think it's better to put it here. And this is going to be 1 and 1. Yeah, let's talk about it later. Yeah, let's talk about forward function later. The reason we have 5 batch norms rather than 6 is because we are going to do batch norm after linear 3. And yeah, I think that's all about the init function. Yeah, now let's look at the forward function. And when you call an object which created according to the class definition, and you just you only need to pass the x. X is the input, and it can return the value through the forward function. Yeah, now let's implement forward function. First, we need to load by says. Yeah, let's talk about it later. So. Increase dimensions through we can also define the redo function here. And we are going to repeat it 3 times. Yeah, and now we're going to we come to the mass pooling part. And I think we need to reshape it to batch size and it means that the torch will calculate this dimension automatically for you. So I think for at first we have at first I think for example we have 2,000 points and 3, and now it's going to the last we this 3 until now we only modify the last dimension, so we change the last dimension to 1024, and here we after the mass pooling the shape becomes to I think the second dimension has not been changed, so and it's 1024, and yeah, that's before the max pooling, and sorry, and after the max pooling, the last dimension becomes to 1, and we can also use squeeze function now, but I think it's both okay. You can also use squeeze -1. So yes, now it becomes to sorry. Yes, and I think the most important thing to understand a model of deep learning is to understand the data flow. So after each step, you must keep in mind that before the step, what's the shape of data, and after the step, what is the shape of data. I think the reason why deep learning model is difficult because sometimes it's uh, complicated, and but it all boils down to add, minus, uh, multiplication, and division. So it's just a basic math. So I think always keep the yeah. So uh, it's my habit to record the data shape uh, as as annotation. I highly recommend you to do it when you are coding. And comments, high quality comments is good for others to understand your code, and after a few days, it's also help you to understand the code. So yes. Now we have to we are going to decrease the dimension. And it's important that in the last linear layer we are not going to do batch norm, and we are not going to use random activation function. So it's just a linear function. And now the shape becomes to I think So it should be 9, the squared value of 3. And now we're going to add an identity function to it. Identity. So I think it's this should be just 1 0 1 0 0 and yeah, it's very easy. Just an identity matrix 3 by 3. So let's create it. Yeah. I think it's better to change it to init dim for better understanding. And require scrach to make it learnable. And we're going to repeat it batch size times. If you are going to add two data, you have to make sure that they are on the same device. So we're going to move it to CUDA. Remember that the X is not a matrix, so first we need to reshape it to a matrix. So the first size, the first dimension is by size, and we has never done anything to this dimension, and you can even ignore this dimension. And now it becomes to by size 3 3, and it becomes to batch size 3. It's also 3 by size 3 by 3, so we can just add them together. And yes, I think that's all about the TNet. So let's I think after when you are trying to understand a model or you have built a model, you don't need to load the data, which is also several, which is if you run very large, you can just test it to make sure that it works well. So the way to test it is that you can just initialize a tensor and you send the tensor to your model, and you're going to check that if the output is the same as you want. And this means that when you call this function, the code below will be executed. So we just we can set the backside to 16, and we have 2000 points, and each have 3 coordinates. and our model equals t. We do have to send in the parameters because we are going all use the default value of the parameters. And yeah, you just need to send the input to the model. And because we have the forward function, so it will be automatically processed according to the forward function that we have defined. And yes, we can change. Hopefully there will be no bugs. So let me check it. I think yes. Yeah, let's run this file. Oh, I think um, indented indent doesn't match any alternative. So I think yeah yes, I think I should use a tab rather than space. Yes, let's do it again. I wish no error will occur. Torch.functional has no attribute renew, so maybe I should use a capitalized letter. So I think it might be. I think can't find. And dot modules dot activation dot renew. So I don't know why the it be should be this. Oh, let us try. Let me try it again. Yeah, another bug occurs. I think we should have 1024 channel, but got 2000 channel instead. And let me check which file code goes wrong. And in the self.bn1. Yes. I know where you go wrong. It should be anything. We are going. We'll start from anything to the next thing. So let's run it again. And then equals 3. my theme is. It's still this kind of code. So the reason it got 2000 channel instead, and we got backside equals 16 and 2000 points. Each has 3 channels, and count 1. Here we define the kernel size as 1. Actually, I don't know why it goes wrong. Let me check it again. Then NADM should be 3. It said it got 2000 channels instead.